Voltage and current division. Now let's talk about voltage division first. Now, if you have a voltage source here of some value called Vs, and you have, let's say, two resistors here, we'll call them R sub 1, R sub 2. Now, I said voltage division, not current division. Why? For this example. You only have what? Single loop. In a single loop, the current is what? The same. So there is no current division. The current is not going to split. So it's going to be the same current going through the whole circuit. So if I draw a current, I said the current through, if you have only one source, it's going to go minus to plus. So the current will travel this way. That's the direction of the current. So it's going to mark this plus to minus. We'll call it V1. It's going to mark this plus to minus V2. I want to derive the equations for you. So after I derive them, from now on, you never have to derive them. So if you do KVL, Kirchoff voltage law, which says sum of the voltages in a closed loop is equal to 0. Let's add all the voltages in a closed loop. There's a closed loop. Minus to plus, I'm going to use minus Vs. Plus to minus, I'm going to use plus V1 plus V2 is equal to 0. Now I'm making the assumption when I do this one, I know what Vs, I know what R1, I know what R2. So I'm just not giving you numbers for them. So my equation becomes V1 plus V2 equals Vs. There's two unknowns in that equation. That's V1 and V2. That's Vs. Two equations by two, one equation by two unknowns. This is one equation. There's one unknown, that's another unknown. As I said, Vs, R1, R2, we normally know them. Okay, Ohm's law says V1 equals what?
R1 times I.
Times I, yes, and V2 equals what? R2 times I. V equals R times I. So if I replace V1 and V2 in that one by R1I and R2I, I get R1I plus R2I equals Vs. Factor the I out. And what's I equal to? Vs over R1 plus R sub 2. If that's the case, what do we know about now V1? We said V1 is R sub 1 times I. This is I, multiplied by R sub 1, will be R sub 1 over R sub 1 plus R sub 2. I'm going to put the Vs at the end. And V2 is going to be R sub 2 times I. This is R sub 2 and this is I. Multiply them. It's going to be what? R sub 2 over R sub 1 plus R sub 2 times Vs. Those are the equations I use for voltage division. Those are my equations. I just wanted to derive them. So that's the derivation, the math behind them. It makes it nice because if you have a problem, you don't have to calculate the current, go through it, and all this stuff. If you know these equations, you know what the answer is. I'll give you some numbers for this example. 20 volts, 4 ohms, 10 ohms. I want to know the voltage here, we'll call it V1, and I want the voltage here, we'll call it V2. So V1 using voltage division is going to be the source, or I'll write it the way I did there. It's going to be R sub 1. So I'm looking for V1, which is this one. I'm taking that resistor. That's your R sub 1. Notice if you look at the equation, when it's V1, what do you have on the top? R sub 1, its own resistor, over the sum of them. When it's V2, what do you have? R sub 2 on the top, divided by the sum of them. So if I'm looking for V1 here, that's this voltage right here, so it's going to be that resistor on the top divided by the sum of them times the 20, whatever the source is. That's 80 over 14, and that's 40 over 7. If I'm looking for V2, V2 is this voltage, I'm going to use that resistor, which is 10 over the sum of them, 4 plus 10 times 20. That's 200 divided by 14, which is what? 100 over 7. Now, if I add these two voltages, what should I get? What do you think I'm going to get?
20.
Better be 20. So it's 20 volts. It should be, because that's what the source is. The voltage is going to split. They're all going to share that value. When you add them all, that's your answer. Now, usually the problem is a little bit more complicated than that. So I'll give you one that's a little bit more challenging than this. Pick a number. Go ahead for a voltage source. Any number?
12.
12? Okay. We have two resistors in parallel here. Pick some numbers for them. Anything you want to. Go ahead.
8 and 10.
8 and 10 ohms. And we have a resistor here and a resistor here. I'm trying to put color ideas together. Let's pick some values for these. It's your problem, so choose any number you want.
5 and 9.
5 and 9. Good. And what I want to find, the question is, what is the voltage right here? I'm going to call that Vx. And what's the voltage right here? I'm going to call that Vy. So find Vx and Vy. What do you think we should do? How are we going to do that?
Try to make the two parallel groups into like each one
Okay. Those in parallel, which means the voltage across them is what?
the same.
The same. So if I combine them, do I lose that voltage? Do I change it? No. So let's combine them. When you have two resistors in parallel, the equivalent value is the product over the sum. 10 times 8 is what? 80 over what? 10 plus 8, 18. And that's your Vx. This is Vy. And the value of that, the product over the sum, 9 times 5, which is what? 45 over the sum of them, 5 and 9, 14. If you want to make life easy, you take your calculator and divide them now. 80 divided by 18, 4.44. And this one, 45 divided by 14, 3.21. So let me find Vx using voltage division. It's this resistor, which is 4.44, divided by the sum of them, times the source, which is what?
12.
2. Oh, 12, yes. I wrote 2. So here we go. 4.44 divided by parentheses 4.44 plus 3.21 close parentheses equals, you multiply that by 12, I get 6.96. And Vy, it's going to be this resistor, which is 3.21 over the sum of them, times the 12. 3.21 divided by parentheses 4.44 plus 3.21, and you multiply that by 12, and it's 5.04. And notice, if I add this number to this number, what are you going to have? 12 volts, which is the source. So that's how we handle voltage division. And it doesn't have to be 2 resistors, by the way. There could be 3, 4, 5, and still the same thing. I'll do one more example just to show you. If you have 3 of them or 4 of them connected in series, that's the only time you can use voltage division, when they are connected in series. They have the same current. R1, R2, R3, RL, doesn't matter how many we have. It's going to be V1 here, V2 here, V3 here, VL here. Again, I'm making them plus to minus because I'm making the assumption, because the source is minus to plus, the current will be going this way. And that'll be the correct assumption. So V1 will be R1 divided by what? R1 plus R2 plus R3 plus R sub L times Vs, whatever the source is. V2 will be R sub 2 over R sub 1 plus R sub 2 plus R sub 3 plus R sub L Vs. R sub V3, I think you get the idea. It's R sub 3 over R sub 1 plus R sub 2 plus R sub 3 plus R sub L times Vs. And you can give R sub 4 and V4, V5, VL, whatever you want to do. They all have the same look, except when it's V1, you have R sub 1 on the top. When it's V2, you have R sub 2 on the top. When it's V3, you have R sub 3 on the top. The bottom is the same. The source is the same. That's your voltage division. Let's look at current division now. Current division, again, when you have parallel. And I'll do it with 2 for now. So let me write current division so we know what that topic is. Again, let's say you have a current source, I sub S R1 R2. Notice it's not called a voltage division. Why? When they're in parallel, what do we know? They all have the same voltage. So voltage is not going to split. Only the current is going to split. I sub S is going to go in. It gets to a junction here, it's going to split. Some will come down this way, we'll call it I1. The other one comes down this way, we'll call it I2. So if I use KCL at the top, KCL says if you take all the current going into a node, if you add them all, it should equal all the current coming out of that node. And what is going to that node? I sub S. And what's leaving that node? I sub 1 plus I sub 2. Very good. How many unknowns in that equation? We know I sub S, we know R1, we know R sub 2. So I know this one, but I don't know I sub 1 or I sub 2. Now we said they're all connected in parallel, which means they have the same voltage. Let's call the voltage across them all V. Now think of Ohm's law. Can you write I sub 1 in terms of V and R1? I sub 1 equals what? V over R sub 1. And I sub 2 equals what? V over R sub 2. So now if we take this equation here and replace I sub 1 and I sub 2 by these values, you will have what? I sub S equals V over R sub 1 plus V over R sub 2. If you factor a V out, one over R sub 1 plus 1 over R sub 2. Now, if you do the math here, LCD is what? R1, R2. This will be R2 plus R sub 1. LCD. So what's the voltage? I sub S divided by, I'm going to write that instead of R sub 2 plus R sub 1 is R sub 1 plus R sub 2. And when you divide by this fraction, that's the same as multiplying by what? R1 R sub 2 over R1 plus R sub 2. Ready now for them? So what's I sub 1 equal to? V over R sub 1. This is what V is. If you divide this by R sub 1, what's going to happen to that R sub 1? It's going to cancel. Do you see it? So it's equal to, you can put the I sub S at the end or in the front. R sub 2 over R sub 1 plus R sub 2 times I sub S. And I sub 2 equals what? Here's I sub 2. It's V over R sub 2. So this R sub 2 will cancel R sub 2 on the top. If you take R sub 2 out of this, what do you have? R sub 1 over R sub 1 plus R sub 2 times I sub S. And those are the equation for current division. Notice when it's I sub 1, I'm going to use which resistor on the top? R sub 2. When it's I sub 2, I'm using what on the top? R sub 1. the opposite resistor. So those are the equation for current division, right there.
What if you had three?
Huh?
What if you had
You'd only get rid of one still. For the first one, it would be I sub 1 R2 times R3 divided by R1 plus R2.
The question, if you get three of them, the math becomes a little bit hectic, so what it might be worth it is to do two at a time. Because the question was, what about if you have three of them? And if you have three of them, and if I label the current as I sub 1, I sub 2, I sub 3, I sub 1, I sub 2, I sub 3, right? So we can do KCL just like we did with the 2. We just repeat the process just like this, but with 3 now. We'll say I sub S equals what? I1 plus I2 plus I sub 3. And I sub 1 equals V over R sub 1. I sub 2 equals V over R sub 2. And I sub 3 will be what? V over R sub 3. You'll see the math gets a little bit ugly. So when I plug them in, I can factor a V out. We have 1 over R1 plus 1 over R2 plus 1 over R3. And boy, oh boy, that's not pretty. Because what's your LCD now? R1, R2, R3, right? LCD for these fractions, R1, R2, R3. So this one will be R2, R3 on the top. This one will be R1, R3. And this one will be R1, R2. If you find the LCD, write them individually and combine them. So what is V equal to? I sub S over this, which means multiply it. That's R1, R2, R3 over R2, R3, R1, R3, R1, R2. So what is, that's V. So what is I sub 1 now? I sub 1 you divide by R sub 1. When you divide by R sub 1 is gone. So I sub 1 will be, take out R sub 1 will be R2, R3 over R2, R3 plus R1, R3 plus R1, R2 times I sub S. And I sub 2 will be, I sub 2 is sitting on top of R sub 2, so R sub 2 is gone. So it's R1, R3 now I never do them this way. Never will, probably. So I'll do an example and show you how I will handle them. And you can get 3. And if you have 4, it get even worse, the math. So I'm only going to pay attention to 2 and steal that idea when I have 3 and 4. I'm just going to use this. When I have 3 and 4, I'll show you what I'll do with them. So let me make an example. Here's my circuit. Pick a value for the source. Go ahead. It's early, so we can make you up. What is it? 8, somebody said?
Yeah.
8 amps. We have 2 resistors in parallel. Go ahead.
6 and 4.
6 and 4. The best thing you can hope for, the resistors are equal. Because if they are equal, what will happen to that current? Split in half. You don't have to do any math to it. Boom, done. So this is I sub 1. This is I sub 2. So I sub 1, according to my equation, notice I sub 1 is with the 6 ohm. So it's not this resistor, it's the other resistor. It's 4 over the sum of them times 8. 4 times 8, 32. Divided by 10, 3.2 amps. What is I sub 2? It's 4.8. Why? They have to add up to what? 8 amps. So if you don't want to do it, you can figure it out, but I'll do it. I sub 2, this is I sub 2, this resistor. So I'm going to use that one. So for the voltage is the same resistor, for the current is the opposite resistor. So now 6 over what? 4 plus 6 times the 8. 6 times 8, 48 over 10, which is what? 4.8 amps. KCL said if you take all the currents going to the node, should equal all the currents leaving that node. Well, what is going to that node? 8, and what's leaving? 3.2 and 4.8. Do they add up to 8? It better be. They have to add up to 8. Now I'll put 4 resistors and do it with 4 and see what will happen. Again, so each one of you guys pick a value. I'm going to throw a source. Vitaly, give me a number for the source. 6. Sam, go ahead. Resistor here. 10. Who's been quiet? Alex, go ahead. Lucas, I mean. 15. Now I block out. Eric. I say Alex.
5.
Luke, 5. Eric's 5. Okay, 5 here. 15, Lucas said. I need one more. Todd.
25.
25, you said?
Yeah.
Okay. And the question, I want to find the current in each one of them. I1, I2, I3, I4. And I don't want to do it the other way. I mean, I can find our equivalent for them and want to, and do it that way. Find what the voltage. That's another option, right? Find the equivalent of these resistors, which is one resistor. Once I know the current, I can find the voltage. If I know the voltage, I know the current through each one of them. The voltage divided by 10, the voltage divided by 15, the voltage divided by 5, the voltage divided by 25. Fine, there's nothing wrong with that approach. But I want to practice current division. So how would I do this with current division? I'll simplify it. I'll take this 6 and I'll say, you know what? I'm going to take this and redraw that like this. This is the 10, this is the 15. And I'm going to redraw these two like this. That's exactly the same circuit. I just made the wire, instead of attached there, I add an extra wire and attach it right there. That's still I sub 1. This is still I sub 2, no change here. This is I sub 3. This is I sub 4. This current here, I'm going to call it I sub x, which is the sum of 1 and 2. And this current here, I'm going to call it what? I sub y, which is the sum of this and that. because that's a node here, connecting these points. That's a node. Can I find the equivalent of these two? The product over the sum. 10 times 15 is what? 150. 150 divided by the sum of them, which is 25. What's 150 over 25? Is that a 6? That's 6. And this is I sub x now. Good job choosing these numbers. I don't know if you planned it that way. How about that one? This is I sub y. 5 times 25 is what? 125 divided by 30, the sum of them, the product over the sum.
4.16.
4.16. Now I can use current division to get I sub x and I sub y. Do I know what I sub x is? I sub x will be, it's that resistor, 4.16, divided by the sum of them. What's 4.16 plus 6? 10.16 times the 6 amp. $2.46. Can I find I sub y? I sub y, gotta use that resistor. 6, or I can subtract it, right? 6 over 10.16 times the 6. That's 36 divided by 10.16. 3.54. Notice if I add the two numbers, they should add up to what? 6 amps, the source. Well, I know what you're thinking, like, who cares about I sub x? That wasn't the question. The question, what is I sub 1, what's I sub 2? Let's go one slide upward, right there. If I know what this current is, can I figure I sub 1, I sub 2? Current division one more time. So now, I sub 1 is going to equal to 15 over the sum of them, which is what? 25 times I sub x. What is I sub x? 2.46. I'm looking for that current. So it's that resistor over the sum of these times the current entering the node, which is 2.46. So 2.46 times 15 divided by 25. 1.48 if I use 2 decimal places. I sub 2. I sub 2 is this current, so I got to use that resistor. 10 over 25 times 2.46. 24.6 divided by 25.98. Can I get I sub 3? I sub 3 is this current, so I have to use that resistor. 25 over the sum of them. What's 25 and 5? 30 times the current I sub y, and I sub y happens to be 3.54. $2.95, and I sub 4, the last one, should equal, I sub 4 is that one, I got to use this resistor, 5 over 30 times what? 3.54. which is 0.59. Now, if we did the problem right, I mean, not counting rounding errors, if I add them all, they should add up to what? 6, whatever the source is. Let's see what that sum is. I might be off by 1/100th because of rounding errors. 1.48 plus 0.98 plus 2.95 plus 0.59. Notice I'm just writing all these numbers. I'm going to hit enter, should be close to 6. 6 on the money. Sum of the current entering the node should equal sum of the current leaving that node. So if you have more than one, try to simplify your circuit. So let me try some problems here, go through them, and see if we can analyze them, see what will happen. Maybe I'll put a dependent source in the problem too. I'm just looking to see if I left anything out in the chapter. It doesn't look like it, so okay. Let me find something that looks a little bit ugly. Try to tackle it. Okay, I found one. I was looking for the ugliest one in the back of the book. And I think I found one. I didn't want it to be simple. So make sure you have a lot of space for this to draw. 6 amps. So we're trying to put everything that we learned so far together. That's, I think it's a 3. God, I need to get new glasses. This is 15. Six. Dependent source, the value of 2i, hopefully we'll find where I is. Another source here of 3 amps. Another resistor here of 6 ohm, another resistor next to it of 6 ohm, and this is I, by the way, the current through the second one, and we have nine amps coming down. That's what my circuit looks like. The question here, determine the power absorbed by the 15 ohm resistor. By the 15 ohm resistor. So the power by the 15 ohm resistor is going to be the current through that times the voltage across the 15 ohm resistor, right? Or the current through the 15 ohm resistor squared times R, or what? The voltage across the 15 ohm resistor squared divided by R. So if I know the voltage across that, or the current through it, or the voltage and the current, I can find the power. Any one of them. I see three sources there. How are they connected? Look at this source, look at this source, look at that source. How are they connected?
Parallel.
Parallel. On the top and the bottom together. Notice the top of this, you got a wire attached to all of them. The top to the top. The bottom of this to the bottom to the bottom. There's no other elements here. So I can take the three sources and put them together, combine them. I get 6 pushing up, I get 3 pushing up. Together, how much?
9.
9 up, and I get 9 down. What will happen? They cancel each other out. The net result is 0. Why? Because the current entering a node should equal the current leaving the node. If you look at the math, if you look at the top, what's entering? Don't pay attention to these. Just look at these three sources. This is entering. You have a 6 on this end, right? Plus, you get a 3 on that end. That's equal to what? 9 equals the current leaving. You get that 9 leaving. You get an equation with 9 on this side, 9 on that side. What will happen mathematically to that? They will cancel each other out. So they cancel each other out. So I don't even have that source there. So if I redraw that picture, I will have this. I'll put this one first. I like the source first. I can take these two, combine them into one for now. The product, 3 times 15, which is what? 45. 45 divided by what? 18. I need to know what that voltage here. If I know that voltage here, I can find that's the voltage across the 15 ohm resistor. They're in parallel. So by combining them, I don't lose the voltage. 3 times 15 is 45 divided by 18.
2.5.
2.5 even?
Yep. Can we combine that with the 6?
Well, I will eventually. I just want to do them one step at a time, because if I combine them, I lose the V now. So I'm okay with losing the V as long as I keep track of everything else. Notice these 6s, I can combine them. I still don't want to combine them because why? You lose I, exactly. So this circuit is really this now. A little bit easier. You wanted to combine these two, right? Well, if you combine these two, you're going to lose V. I'm okay with that. As long as I have that picture above there. .5 and 6 is what? 8.5. Now I lost V. I get the 6. And I got here 6, which is I. Can I combine these two?
Yes.
The product over the sum. .51 divided by 3.52. the hell did I get my number from? I killed the circuit now because I can't solve it with the numbers I use. The number is 4 actually, not 6. That's the problem. Because I'm looking at it now, I can't solve it. Why? I can do current division, but you'll see the math doesn't make any sense. If you want to find that current with that, that's why I had to grab the book and look at it. If you look at that one, current division, you go, well, this current's going to come. Some will go this way, some will go that way because the source is pushing it that way, right? So that current, which is negative I, should equal, well, the name of it, it should, so if I'm looking for that current, I'm going to use this one over the sum of them, this and this, which is what? Times the value of this, which is what? 2I. And notice the I cancels the I, and the math doesn't make any sense. You get a negative 1 equals that, and that's not equal to negative 1. So I knew something wasn't right, so I had to look back and see. It was actually a 4, not a 6. So if I go back and doctor that problem just a little bit here, because I wrote the wrong value.
The only thing that would change, wouldn't you just have like a 4 amp or a 2 amp source there?
It will have a net result will be a 2. Yep, let's see. So if I put a 4 here, so that's 4 plus 3 going up, which is 7, and 9 down. That will leave me with what? Down 2, right? So now I'll come back here and I'll add 2 down and 2 down. Now we can finish this. I can't really, I'm not going to use current division here. Not I can't. I don't like it for this problem. Maybe I'll do KCL. There's only one node. They're all connected how? In parallel. That means what? The voltage is the same. Which is the same voltage right here. That voltage here is the same voltage right there. So if I know what that voltage, I'm done. I'm almost done. Let's call this current coming down I sub x. So if I do KCL at the top, what do we have? What's the current going into that node? From my pictures, do we have anything going to it? The way my picture is drawn, there is nothing going to it. You can say negative 2, but I'll just go 0 going to it. What's leaving? The 2, the 2I, I sub x, and I. So negative 2 equals what? 3I plus I sub x. And if I can write I sub x and I in terms of V, the problem is done. What is I equal to in terms of V? Isn't it V over 6? And what's I sub x? Isn't it 3.52, V over 3.52? So that's what I and I sub x equal to. Let me put them in now. 3 times I, that's V over 2, is it? 3 over 6, which is what? 0.5 V. plus I sub x. What is 1 over 3.52? I have a calculator, why kill myself? 0.28. Negative 2 equals what? 0.78 V, and V equals negative 2.56. Wonderful. Now I know I sub x, right? What's I sub x? I sub x is going to be negative 2.56 divided by what? 3.52.
We don't need to know that, though, do we?
Well, if you know the current through this, I'm going to work it backward.
Well,
Then you know the current through the other one.
We're going for the,
Or the voltage.
We're going for the power.
Yep.
through-
Well, the power, you need to know the voltage or the current. One of them.
Don't we know the voltage?
We know the voltage across the whole thing. Notice that 8.5, what is my other picture? The 8.5 is the combination of both. So I can use voltage division if I want to find that voltage, or I can calculate the current through that, and once I know the current, I squared divided by that resistor. So either way. So since I almost have the current in front of me here, I go, let me find the current, which is negative 2.5 divided by 3.52. And I sub x equals negative 0.728 or 73 amps. Remember, the 8.5 ohm resistor, it's really the combination of these. What the math is telling me, I defined the current coming down, and the value is what? Negative 0.73. It says you are wrong. It should be going which way?
Yeah.
Upward, and what's the value? 0.73. So the current through that really should be up there. If you go now backward, it should be 0.73 amps. So I know what the voltage right here now. The voltage here will be what? So if you look at that circuit here, I'm just looking at that little branch here. There's the 2.5, and there's a current going through it upward, and the value of the current 0.73. That makes this voltage plus to minus, we'll call it VZ, which is the backward to V. This will be plus, that'll be a negative. Doesn't matter. So VZ is going to be what? Ohm's law, 2.5 times 0.73. Times 2.5, roughly 1.82.
Where's the 2.5 coming from?
It's the
Resistor, was that 2.5?
Yeah.
Okay.
6 and 2.5 in series. Remember, that's not the current through the 15, that's the voltage, but the voltage happens to be the same for both them. So if I know the voltage here, I know the voltage here. So that V really is negative because this V is plus to minus, that V is plus to minus. So if you want to find V, which is the voltage here, that's going to be negative 1.82 volts. That voltage here, which happens to be the voltage right there.
We can just switch a sign on the voltage.
Yep, doesn't matter because you're going to square it. What's the power now? It's V squared over R. We're talking about the power through that resistor, the 15, not the 2.5, the 15. We know the voltage across the 15, which is what? 1.82. Put negative, go ahead, square it, divided by R, which is 15. Do the math. And it's 0.22 watts. That is the average power absorbed by that resistor.
0.22 watts.